Okay, so now here the problem is that there is an ML course going in some university, and teachers want to know exactly, or the instructor wants to confirm whether the student, that is whosoever he or she is good in maths and stats. Why? Because maths and stats are the basic property of the machine learning or the data science. So what they did, they actually take the data from the students by asking them what exactly their scores were in mathematics and stats. And after that, they can simply train the model by making the model learn about mathematics score and the stats score. And then the machine learning model will actually let you know, okay, if the score is this, it is good. If the score is that, then it is bad. So ML is basically giving you what kind of information? That the student pursuing the course will be good or bad. Fine. Now this is the actual problem, जो कि मैंने भी बोला. अब now the prerequisite is mathematics and stats. That means जो बच्चा mathematics और stats में अच्छा होगा, वो data science में भी अच्छा होगा. Can I infer that? Yes or no, class?
Yes, yes, yes.
So undoubtedly, this is what exactly the problem is. So now it is not like जो बच्चा सिर्फ maths में अच्छा होगा, वो data science में बहुत अच्छा होगा. जो बच्चा सिर्फ stats में अच्छा होगा, वो data science में अच्छा होगा. It has to be both the thing, or it has to be defined. So what they did, this is the problem. So now thing is कि one of the student came for the enrollment that I want to pursue machine learning. So the instructor simply asked for, okay, what are your mathematics score and what are your stats score? The moment that student told the instructor that my mathematics and stats scores are this much, the machine learning model automatically tells whether good or bad. So how it has been done. So what they did, they actually plotted a two-dimensional plot of both maths and stats score. So now maths and stats score को जब बनाया गया, मतलब डेटा कलेक्ट किया गया जितने भी स्टूडेंट्स ने एनरोल करा था, उसके बाद मैथ्स और स्टैट्स स्कोर को हम लोगों ने प्लॉट करा. They plotted it. It comes like to be this one. So see, on the x-axis, the math scores are there. On the y-axis, the stat scores are there. Right? So हमने क्या करा? Feature to feature, because there were only two features, that is mathematics and stats. तो हमने mathematics और stats features को represent करा और हमने उसको plot करना शुरू किया. जब हमने उसे plot करना शुरू किया, we defined two different labels, good and bad, by red one defining the bad and green or blue one defining the good. Getting my point? So now they are good and bad. So क्या करा गया? x1 और x2 के according averaging करी गई, and उसके according जो plots जो points आते गए, हमने उसको plot करना शुरू कर दिया. जब plot किया, we got something like this. दिख रहा है सबको? I hope सबको visible है. Now there is something good, there is something bad. So that means जब किसी का x1 और x2 score, that means x1 maths का score और stats का score किसी का 1 और 1 है, any range, let it be 0.75 और जो भी उनका grading system रहा होगा. So that person belongs to the bad state. That means machine learning algorithm will simply say that person cannot pursue the machine learning algorithm, machine learning course. If I'll say somebody is having score of 7 in maths, 7 in stats, that person is falling in the data point of blue one. That means that belongs to the good class. So now the machine learning model will simply state, it will predict that the person is good in, person will be good in mathematics, stats. Okay. This is what exactly is defined by the scatter plot. Now, how exactly we are looking into this? Now, since there is a clear demarcation over here that the two different sets are well labeled and they are at a distance from each other. So, plot करा हम लोगों ने, scatter plot करा, scatter plot करने के बाद Okay, class. So if I'll go with the plotting of this, so it will be looking like what exactly the problem will be giving you a solution. Yes. So now some of the points of bad are over here and good are here. तो ये मशीन लर्निंग मॉडल ने डेटा पॉइंट्स को प्लॉट करने के बाद बनाया. And now class, just see, at this axis there is for mathematics, at this axis it is for the stats. Now there is a clear demarcation that we can simply split these two scatter data points into two different halves. सबको दिख रहा है clearly?
Yes, ma'am.
Yes, ma'am.
So now it is very clear. Now the only problem with the machine learning algorithm or for us is how to draw this line. ये कैसे बनाई जाए? Now this is basically called as a decision boundary. Right. Now this decision boundary is actually doing what? It is actually telling the algorithm, or it is actually giving us the information that below this, no matter whatever data point come, belongs to bad data category, and above this, any point will be a good category. So now there are two regions. So basically it is a binary classification problem. So whenever we have to go for two-way classification or two-set classification, good, bad, yes, no. So we are going with SVM, and SVM actually gives you a very good accuracy. Now, how to identify where to plot this decision boundary? This is the biggest question. So now, if I'll say, suppose I have another data point over here. तो जब ये data point आएगा, तो what will happen? सपोज मेरे को ही एनरोल करना था, मैंने मशीन लर्निंग सिस्टम के लिए कोर्स के लिए एनरोल करा, मुझसे पूछा गया ओके व्हाट इज योर मैथमेटिक्स एंड स्टैट्स स्कोर. नाउ दिस इज व्हाट एग्जैक्टली I got good in maths, but I didn't got very good in stats. Now my data point belongs to this. So exactly कहाँ पर है? Will it fall in bad category or in a good category? Now another data point. Suppose प्राची ने भी ज्वाइन किया, प्राची ने कहा ठीक है मैं भी अप्लाई करती हूँ. She is, let her point be this. Now she entered her score into this, and machine learning algorithm plots her near to this. Now what will happen? Which she belongs to? She belongs to good class. So now the problem is any point. So now exactly क्या किया? Data points लिया, machine learning algorithm को दिया, scattering plotting कराई, plotting कराने के बाद we got to know two different classes. They demarcated. हमने एक डिसीजन बाउंड्री बनाया. डिसीजन बाउंड्री अब कैसी होनी चाहिए ये हमारा क्वेश्चन है, लेकिन डिसीजन बाउंड्री के साथ हम लोगों ने ये भी चेक करने की कोशिश करी कि अगर कोई नया टेस्टिंग पॉइंट आया वो कैसे बताएगा कि एग्जैक्टली वो कौन सी क्लास को बिलोंग करता है, गुड को या बैड को. फाइन. सो नाउ व्हाट हैपन, यहाँ पर वो काम हो गया, लेकिन अभी भी क्वेश्चन क्या रह गया है कि हाउ टू डिफाइन द डिसीजन बाउंड्री. सो व्हाट वी हैव टू गो फॉर, जैसे हमने लीनियर रिग्रेशन में कहा था, हमने लीनियर रिग्रेशन में क्या कहा था क्लास, जब भी मेरी लीनियर जो भी हम लोग लीनियर रिग्रेशन की लाइन बनाएंगे, इफ द पॉइंट्स आर वेरी फार ऑफ द एरर रेट इज हाई, यही बोला था. इफ द पॉइंट्स आर क्लोजर or almost near to the linear regression line, accuracy will be more. Similarly over here, अगर मेरा टेस्टिंग पॉइंट it is having the maximum distance from the decision boundary, it has to have the maximum distance from the decision boundary on both the edges, then I'll define it to be the margin. जो हम लोगों ने कल कहा था ना road, then I'll define it to be the margin. So this is exactly what it is saying here. We have two images, so you tell me कौन सी वाली, फर्स्ट वाली इमेज को देखो और सेकंड वाली इमेज को देखो. सिर्फ इमेज को देखना है और कुछ नहीं करना. फर्स्ट वाली इमेज में किसी को कुछ गलत दिख रहा है? Keeping in mind the distance between the data points should be maximum. फर्स्ट इमेज को देखो और सेकंड इमेज को देखो. Which one according to you people is the right one?
Second one.
Second one.
Why second one?
On the distance between the points is maximum in the second one.
Exactly.
मैम उसमें जो पॉइंट वो उनके बीच का लाइन के बीच
Exactly. अगर तुम ध्यान से देखोगे फर्स्ट वाले केस में यहाँ पर ये 2 ब्लू पॉइंट्स दिख रहे हैं सबको. आई होप मेरा कर्सर दिख रहा होगा. इस क्लास से 2 पॉइंट सबको दिख रहे हैं. फर्स्ट इमेज में देखना. The 2 blue points are very close to the decision boundary, and similarly the 2 red points below at point 5, they are also very close to decision boundary. So it will be like they will be, no matter when the new testing set comes, you misclassify kar jayega. But in the case of second one, we'll simply say it is more of linear and undoubtedly distance from both the sides, from good side as well as from bad side. Distance from the data points towards the margin is comparatively equal. So now
Yes,
the thing is कि undoubtedly if there is a testing point, misclassification होने के chances बहुत कम है. So we have to identify like this, which one is a better decision boundary. So always understand it has to have both the side, it has to have a proper distance. So maximizing the distance. So this is what exactly we had done. So ये चीज मैं यहाँ समझा रही थी. I hope सबको यहाँ पर रेड कलर का बॉक्स दिख रहा होगा फर्स्ट इमेज में. तो रेड वन इज बेसिक, रेड कलर का जो बॉक्स है दैट इज बिलोंगिंग टू red color one is actually belonging to the bad class, but by default it should belong to good class because it is closer, it is much more closer to this blue scatter points. Fine. Similarly over here, this blue one, blue square is actually, it should belong to red class, but undoubtedly it is showing by after plotting the decision boundary, it is actually showing much closer to the blue class. Getting my point? So now first image is actually giving you the wrong impression, but in the second case, देखो बिल्कुल clear demarcation है that red one will your this red box is belonging to red side and blue box is belonging to blue side. Getting my point, class? Why? Because जब हमने पहली वाली decision boundary में check किया था, तो distance from these two are close to each other, so my bits will be less. That's the only thing we have to take care of it. And first case will be creating a more risky situation because misclassification will be more in comparison to the second one. Second case में misclassification होने के chances ही नहीं होंगे. क्यों? क्योंकि decision boundary के आसपास कोई है ही नहीं. Clear हुआ class?
Yes, ma'am.
Fine.
Yes, ma'am.
Okay. So now, as per the support vector machine, we have to go for a decision boundary. So now, rather than saying linear regression line, we are going for a decision boundary. So now the decision boundary is being defined. जो हमें दिख रहा है. After this, what we have to go for? We have to go for the correctly identified training data point. So correctly identified data point का मतलब क्या हुआ? यहाँ पर सेकंड वाली लाइन, सेकंड इमेज में अगर देख रहे हो तो वी आर हैविंग द डिसीजन बाउंड्री. These 2 points are blue one and the red one. Blue bubbles and the red bubbles are the training point. So now the training point has to define a region जहां तक उसको लगता है कि यहाँ तक तो मेरा proper classification है. After that, if something goes wrong or some testing point comes, then accordingly it will classify. So what exactly the SPM does, now it will give you a simplified version. It will say there are 2 things that we have to go for. First one is the find lines that correctly classify training data. So we have to define कि okay कितनी range तक या कितने data points तक perfect classification है according to the decision boundary. Second one, among all such lines, pick the one that has the greatest distance from the greatest distance to the point closest to it. So undoubtedly what we have to go for like this. So middle one, the darkest line is basically your decision boundary. The blue line over this decision boundary and below this decision boundary is basically the 2 lines that are actually defining that the data points have been well trained. So this blue bubble falls in the good category despite it is falling on the line. Similarly, the red bubble is actually falling on the same line, but it is belonging to the bad class. Getting my point, class? Clear हुआ class यहाँ तक?
Yes, ma'am.
तो नाउ क्लास जस्ट अंडरस्टैंड हमने क्या कहा हमने डिसीजन बाउंड्री बनाया है सपोर्ट वेक्टर मशीन का काम क्या होता है सबसे पहले एक डिसीजन बाउंड्री बनाती है डिसीजन बाउंड्री बनाने के बाद उसको ये आइडेंटिफाई करना जरूरी है कि जितना भी उसके पास डेटा था वो सारा का सारा वेल ट्रेन हुआ या नहीं हुआ उस वेल ट्रेनिंग के लिए क्या किया वी हैव टू प्लॉट 4 मोर लाइंस दैट इज बेसिकली लीनियर रिग्रेशन हो गया जैसे लाइन होती है वैसे ही हमें 2 लाइंस और बनानी है just for this like why 2 lines because we are classifying a problem as good or bad. It is a binary classification. Yeah, 0, 1, good, bad, yes, no, true, false, this and that, married, unmarried, mammal, non-mammal, sunny, not sunny. Yes, sir. So undoubtedly for that, since there are 2 parameters on which we have to define our labels or the class, so we have to plot 2 different lines. Now what is happening? Undoubtedly, from this image, we are getting to know that the data points are well trained, but few of the data points are on the margin itself. We'll talk about what exactly this margin is doing. But right now, बहुत clearly देखो अगर तुम इस diagram को देखोगे from 7 to 9 on y-axis and from 7 to 9 on x-axis, इस पूरे pathway में कोई plot, कोई भी data plot point exist नहीं करता. दिख रहा है किसी को? Is there any data point that is existing between these 2 points? I mean, from 7 to 9 and from 7 to 9 on both the axes?
No, ma'am.
So, the clear demarcation and the blue one on the different edge and the red one are on different edge. So, there is something called as the margin. Okay. So, the closest point that identify this line are known as support vectors. So the blue bubble with a black circle is basically a support vector because now it is actually telling till this point, decision boundary से लेकर के इस point तक training well to do है. So इसको क्या कह दिया गया support vector. That is, it is supporting a line stating यहाँ तक की line, यहाँ line इस line तक जितने भी data points है they are well trained. And the region defined around the line is known as margin. So, if I'll go with my sketch, so I hope class सबको दिख रहा है यहाँ पर. So, this is the point that is actually defining the support vector because now it is defining that from this decision boundary till this point means till this point the training is well versed and it is supporting that the line at which I am placed till this point the training is being done in a perfect manner. That's the only reason everything is belonging to the good class. Similarly, if I'll see over here, let me take this point as the bad class. So now this point will be considered as a support vector for the bad class because after this, इस point के बाद से जितना भी कुछ है, all are belonging to the bad class. So now from this point till this point is basically the width of the margin. So these 2 points are basically called as support vectors. And और ये जरूरी नहीं है सिर्फ 2 ही points हैं, हो सकता है 2-3 points और आ जाए. अंदर कोई आ गया हो, that is a different thing. It's not mandatory that there will be only one support vector. There can be 2 or 3 support vectors. Fine. So this is basically called as a support margin and जो distance from the point decision boundary से उस point तक का बन रहा है उसे हम क्या कह देते हैं margin. So now this width is actually called as the margin. The area जिस जहां से demarcation हो चुका है कि भाई ये तो good class को belong करता है और ये bad class को belong करता है. Clear है यहाँ तक? This class.
Yes, ma'am.
Clear to everyone. So support vectors are the points from the decision boundary that supports the line stating that the training is well done. Similarly, the margin is the region between the 2 support vectors for different classes is basically called as the margin. Now, this margin actually has some impact. That means it can be wide, and it can be narrow. So we have to think about in that exactly how it works out. So यहाँ तक हमारा support vector और margin आ चुका है. Now, support vector machines gives you a way to pick between many possible classifiers in a way that guarantees a high chance of correctly labeling your test point. So, I say that it is a multi-classifier. It can classify multiple labels. अभी तो हमारे पास सिर्फ इतना था good or bad. So can I go it like married, unmarried, divorcee and single? Can I go it like this? So I mean it is like multi-classification. Mammal, non-mammal, or I can go for okay. If the shape of this particular fruit is this, it belongs to banana, it belongs to apple, it belongs to orange, it belongs to plum, it belongs to papaya. So it is a multi-classification. So can we go for this type of classification using SVM plus? कौन बताएगा? So there is a problem. We can't.
तो टू कैसे करेंगे?
हाँ जी बेटा. So it's difficult. Why? Above plot shows a line and data in 2 dimensions. It must be noted that SVMs work in any number of dimensions, and in these dimensions they find analogs of the 2-dimensional line. So since there are 2-dimensional lines, so class, उसके बाद I have a 1D plot which will always give me a line. Agreed? Yes or no? If I have a 1-dimensional plot,
Yes,
I'll
ma'am.
simply have a line. If I have a 2D plot, then I have a मेरे पास अगर 2D प्लॉट है तो मुझे क्या मिलेगा? लाइन से क्या बना सकते हैं हम लोग? Exactly. So it is a plane. If I have a 3D plot, then it can have a plane, it can have a line, it can have both, it can have multiple lines. So at that moment of time, we'll simply call it as hyperplane. So we'll say 3D plot कैसा दिखता है class? कुछ ऐसा दिखता है ना 3D plot? This is my x axis,
Yes,
y
ma'am.
axis, and z axis. So if I plot something like a plane like this, so now it is having a plane with the axis. So a plane with an axis or a plane with a line is basically called as a hyperplane. So even if I'll go with a 4D, again it will be called as a hyperplane because now there is a fourth dimension being added into the system that can be a time axis. And so again it will be called as a hyperplane. So support vector machine actually creates a hyperplane. Linear regression creates a plane with a line. Or I can simply say that a linear regression will have only the line. But, sorry, hyperplane लिख दिया. But for the case of support vector machine, it creates a hyperplane because now it is having a line along with the plane. So if I say, so this could be my plane with a line. So it creates a hyperplane. So एक ऐसा area जहाँ पर हम कुछ plot कर रहे हैं, demarcation line डाल रहे हैं, decision boundary, margin create कर रहे हैं, so that the vectors or the support system can be there that can simply say that the class belongs to the good class or a bad class. तो अब जरा सोच के देखो, अभी हमने यहाँ पर क्या किया था? हमने एक फीचर को दूसरे फीचर के साथ मैप किया था, प्लॉट किया. If I have 100 of feature, 100 features है, can I do that? Can I have 100D plot? क्या हम 100D plot बना सकते हैं? नहीं बना सकते. Undoubtedly, when there is more number of classification, 2, 3, 4 is okay. But if I am going for 10 classification or 12 classification, it is very tedious for SVM to create a hyperplane. So it can't go for higher dimensions. Though it works very well for higher dimensions. For that, what we are going for, it simply says In 3 dimension, they say they find a plane, and in higher dimension they call it as a hyperplane. So normally third dimension से हम लोग plane बोलते नहीं है, normally hyperplane ही बोला जाता है, क्योंकि हम क्या कहते हैं, plane with a line. So it is basically called as a hyperplane. So just understand, we are working for support vector machine from 3D and 4D. So 2D पर हमें plane मिलने वाला है, so 2D पर हम comparatively we are only working with your features. Now, since there is a hyperplane, the data that can be separated by a line that is in the hyperplane is called as a linearly separable data, and then the classifier is basically called as a linear classifier, or the hyperplane is called as a linear classifier. So classifier in term of, so if I use SVM as a classifier and it is a linearly separable problem, I'll simply say it is a linear classifier. And hyperplane, क्योंकि SVM में create होता है, तो हम hyperplane के लिए भी बोल देते हैं that is a linear classifier. Else it is SVM that is creating the hyperplane. Now, इस data point को, इस data set को देख करके बता सकते हैं how I will define my decision boundary, decision line. It is a linear classifier. Can we draw a linear boundary over here? Margin and decision tree, boundary. Can we draw it over here? Which are actually segregating the red points altogether and blue points altogether. Can we do that?
No.
बना सकते हैं हम लोग? We can't. Because undoubtedly, definitely, जब भी जैसे भी हम लोग linear regression की line, I mean linear plot बनाने की कोशिश करेंगे, कुछ point red वाले will definitely go into blue one, and some points of blue one will be going to the red one. So we have to discard such kind of things. So it simply says that we have to think in that direction. Clearly, if we are using linear classifier, we are never going to be able to perfectly separate the label. So it is like there will be a misclassification. कि हर बार ऐसा नहीं होने वाला है कि बिल्कुल ही segregated तुम्हें डेटा दिखे जैसे previous images में दिखा है. We also don't want to discard the linear classifier altogether because it does seem like a good fit for the problem except for a few errant points. That means there are for the तो भी थोड़ा बहुत अगर 2-4 points अगर blue वाले की तरफ चले गए और 1-2 points red वाले की तरफ चले गए, so linear separable is actually a good fit of line. So undoubtedly we have to work with that. But there are possible conditions जहाँ पर ऐसा नहीं होगा. For example, हमारी क्लास को ले लेते हैं. We are having 7 different departments. All are studying data science. Right? And can I say that all are actually understanding data science? Yes, class, can I say that? Can I? If I am the decision boundary, तो क्या मैं बात बोल सकती हूँ कि these set of students are actually gaining the information related to the data set points, and below my line, these set of students are not actually gaining the good piece of information for data science. Can I say that? आज बहुत easy है ये तो. मैं ये बोल सकती हूँ कि सबको समझ में आ रहा है? सभी को आ रहा है? Or yes or no?
Yes,
Ruby
ma'am.
says no.
Yes, ma'am.
Okay, Nidhi. Okay. So if everybody is saying yes, that means there is no classification because now it is a bias system. तुम लोग bias हो सारे. तुम सब yes बोल रहे हो. हमने last class में पढ़ा था. हाँ.
Yes, ma'am.
So there shouldn't be high bias. It should be a perfect one. So the problem with SVM, अगर हम इसी अपनी क्लास की कंसिडरेशन को लेके चलें, so there will be more number of misclassification. Right? जिसको आता है उसके बारे में पता है, जिसको नहीं आता है उसको उसके बारे में भी पता है. लेकिन ऐसे भी तो स्टूडेंट्स हैं जो ये भी नहीं बोलेंगे कि हमें आता भी है, और ऐसे भी हैं जो नहीं बोलेंगे कि हमें नहीं आता है. Getting my point? They will be in a range जहां पर chances of error is more. तो क्लियर क्लासिफिकेशन नहीं हो पाएगा, तो उस केस के लिए क्या किया जाए? नाउ देयर एट दैट पर्टिकुलर मोमेंट ऑफ टाइम व्हाट वी हैव टू गो फॉर, देयर इज अ पैरामीटर दैट इज बेसिकली कॉल्ड एज अ C parameter over here. This is in the classification only. this actually gives you a piece of information. Basically now it is actually giving you a trade-off between margin कैसी होनी चाहिए. It has to be wide margin or a narrow margin. Fine. So it will be giving you, if I have a wide margin, suppose I'll say, okay, fine. हमारी क्लास में इस टाइम पे 30 स्टूडेंट्स हैं एंड आई सिंपली मैंने प्लॉट किया गुड और बैड में एंड अकॉर्डिंगली आई लैंड अप टू बी लाइक चलो ठीक है मेरी डिसीजन बाउंड्री इतनी है आई विल गो विद दिस एंड दिस एज माय मार्जिन. सो नाउ द विड्थ जो इनिशियली पहले कम थी अब मेरी विड्थ इतनी ज्यादा हो गई है. Now who will tell me what problem the machine learning model will face if the width is more? जिसमें तुम्हें दिख रहा है कि few set of points are being incorporated in between of these from both the sides. Getting my point, class? अब क्या हो जाएगा जब width बहुत ज्यादा हो जाएगी?
Most of the points will fall in this boundary between the width.
Agreed. लेकिन उससे नुकसान क्या हो रहा है? ड्रॉबैक क्या है? What is the drawback? अच्छा चलो एक बात करते हैं. कितने ऐसे स्टूडेंट्स हैं जो रोड ट्रिप
हम
पे
दो
गए?
तरफ से डिफरेंट पॉइंट यूज हो रहे हैं.
क्या कह रहे बेटा? ओके, कितने लोग हैं जो रोड ट्रिप पे गए हैं? I guess everybody has done the road trip. Okay, I personally feel everybody has done gone for the road trip. चाहे बस में जाते हो चाहे हाईवे पे कितने लोग गए हैं? हाईवे. So what is the difference between a highway वाली road and a normal road? कौन बताएगा? ये तो बहुत आसान है. कौन बताएगा? अक्षता. हाँ प्राची.
Highway Valley road is quite smooth and it's easy to drive over there in a clean way, like without
Okay.
stopping in between.
Okay.
limit ज्यादा होती है.
Exactly. Speed limit is
मोर कंपैरेटिवली मतलब इसलिए रख सकते हैं क्योंकि वहाँ पे ट्रैफिक कम होता है क्योंकि रोड वाइड होती है.
Now who will tell me? It is wide. कंचन बिल्कुल सही बोला बेटा. वाइड भी है. नियति ने बोला कि स्पीड बहुत हाई है. So now tell me नुकसान क्या है? क्या प्रॉब्लम हो सकती है if every road will be turned to be a highway road?
मैम स्पीड ज्यादा होगी तो फिर ट्रैफिक
एक्सीडेंटल फ्लोड हो सकता
ज्यादा हो
है.
जाएंगे.
Accident prone हो सकता है. That means the loss of life is there. Getting my point?
यस मैम.
So this is the biggest disadvantage of a highway road. इसलिए क्या बोला जाता है हाईवे से कौन जाएगा जिसको सिर्फ और सिर्फ from one city to another city जाना है. हाईवे नॉर्मली वही कनेक्टिंग लिंक होता है and it is non stoppable. और अगर तुम उस हाईवे को देखोगे तो comparatively every car is moving with a good amount of speed in a controlled manner. चांसेस ऑफ एक्सीडेंट सबको पता है कि एक्सीडेंट होने के चांसेस हाईवे पे बहुत ज्यादा होते हैं क्योंकि स्पीड लिमिट बहुत ज्यादा नहीं है. 120 किलोमीटर पर आवर की स्पीड वहां चलती है. तो नाउ द ड्रॉबैक इज क्योंकि स्पीड कंट्रोल में नहीं है, स्पीड लिमिट बहुत ज्यादा नहीं है, तो अनडाउटेडली एक्सीडेंट प्रोन डिफाइन किया जा सकता है. ओवर हियर आल्सो इफ द विड्थ इज वेरी लार्ज व्हाट विल माय मशीन लर्निंग एल्गोरिथम सफर? एक ही प्रॉब्लम हो सकती है उसे. क्या हो जाएगा जी? अगर वाइडेंड होगा तो क्या प्रॉब्लम आ सकती है? अब तो समझ में आ गया है कि अगर वाइडेंड है और स्पीड लिमिट नहीं है तो अल्टीमेटली क्या हो जाएगा? एक्सीडेंट होगा. तो यहाँ पर क्या होगा?
हम क्लासिफाई नहीं कर पाएगी.
क्लासिफाई नहीं कर पाएंगे. अभी तो हम ट्रेनिंग करा रहे हैं. हाँ मानसी.
मिसकंसेप्शन बढ़ जाएंगे.
मिसकंसेप्शंस बढ़ जाएंगे. मिसक्लासिफिकेशंस होनी शुरू हो जाएगी. एनीथिंग एल्स जो बहुत कॉमनली हम लोगों ने पढ़ा है?
एरर्स आ जाएंगे.
एरर्स आ जाएंगे. सो लेट्स सी. आज देख लो. You have 4 plots. First, second, third, fourth. So C at 0.01 is first, C at 0.1 is second, C at 1 is third, C at 10 is fourth. मुझे जरा बताओगे मिस क्लासिफिकेशन सबसे ज्यादा कहाँ हो रही है?
Ma'am, 0.01.
Why?
Decision boundary बहुत ज़्यादा wide है.
Margin बहुत कम है, बहुत ज्यादा है. So major data points are falling in the margin. So which one will be treated as support vector? क्लास हमने क्या बोला है? अगर सारे के सारे पॉइंट्स यहाँ, अब देखो ना, ये हमने क्या बोला है? डिसीजन बाउंड्री से जो नियरेस्ट वाला होगा लेकिन मैक्सिमाइज डिस्टेंस पे होगा, दैट विल बी क्रिएटिंग अ मार्जिन. बट अब तो ये बहुत सारे पॉइंट्स है. विच वन विल बी सपोर्टिंग एज अ सपोर्ट वेक्टर? ऑल आर सपोर्टिंग. और एट द सेम टाइम हमने एक और चीज पढ़ी है, क्या होता है ओवरफिटिंग? हाँ जी क्लास, ओवरफिटिंग एंड अंडरफिटिंग में क्या डिफरेंस होता है?
Ma'am, training ज़्यादा होती है, underfitting और training कम होती है.
एग्जैक्टली. अब जब आधे से ज्यादा डेटा पॉइंट्स हमारे मिस क्लासिफिकेशन में चले जाएंगे तो ट्रेनिंग क्या होगी? ओवर और अंडर? Exactly over here, this problem will arise. So which one is a better version? Who will tell me? कौन सी वैल्यू ऑफ C के लिए I should go for my SVM?
10.
10. Anyone else? Anyone else? So at high values, it tries to accommodate the label of the most of the red points present at the bottom right of the plot. Fine. Over here. अगर तुम यहाँ देखोगे ये वाली points, ठीक है? This is probably not what we want for the test data. The first plot with C equal to 0.01 seems to capture the general trend better, although it suffers from a lower accuracy on the training data compared to higher values for C. And since this is a trade-off, note how the width of the margin shrinks as we increase the value of C. So it is in between these 2 points. For C equal to 0.1 and for C equal to 1. Margins are comparatively better because over first case, the misclassifications or more number of data points are falling in the margin. And in the last case, we'll see to see it out. So there are more number of red points that are actually acting as a margin for the red class. But for the blue class, major are falling on the margin class. That we don't want. Right? So we should have equivalent from both the sides. That is what I stated in the first thing. So for C equal to 0.1 and for C equal to 1, any of these two could be a possible or the better kind of margin. Definitely the accuracy will for the first case, जहाँ C बहुत छोटा है वहाँ पर accuracy definitely कम होगी क्योंकि more number of misclassification है. At C equal to 10, definitely accuracy better हो जाएगी, but certain other problems will arise into the system. So have to trade it off. दोनों में से कोई वैल्यू लेनी चाहिए. तो ज्यादा छोटी भी नहीं होनी चाहिए, ज्यादा बड़ी भी नहीं होनी चाहिए. It has to be in between of that. Clear हुआ class? Is it okay till this point? So I don't have time now. So on Monday, what we are going for, we are simply going for SVM will be winding up, and we'll start with decision tree. And class today, what I'll do, I'll be sharing you a PDF related to the practical of SVM, KNN, decision tree and random forest. एक ही practical होगा, उसमें तुम्हें classifiers मिल जाएंगे. What I want from you people is kindly get that code in your Google Colab. उसे वहाँ पर import कर लेना. Import नहीं कर पाओगे मतलब type कर लेना. So that on Tuesday, I can simply make you understand what exactly the system is doing.